In this chapter, we're going to be studying rotational equilibrium and dynamics. So the first thing we'll define will be torque. Okay, if you have opened a door, closed a door, if you opened a book, closed the book, if you've raised your arm up, if you have ridden a bicycle, if you've been in a car, then you have basically come across torques. Okay, it's a very important physical quantity to understand. And in this video, we will go over what a torque is. We'll look at all the little things about torques. So consider a simple situation where you have a, this could be a door, this could be a rod, something that is pivoted at this point. So this is the pivot at point P, and we exert a force F at some distance R from the pivot. Okay. Now the force also makes an angle theta with the length of this rod. And this angle theta is important. It cannot just be any other angle. And the way we are going to define it, this angle will be the angle between the force and this R. Okay, so the torque itself is defined as a cross product of two vectors R and F. Okay, now we will write down the magnitude, okay, as simply using the definition for cross product, which happens to be R times F times sine of theta. So if you know R, if you know F, and if you know the angle that they make with each other, we can calculate the torque. Okay, now this is all about this point P. This concept of torque being about a certain point will become important when we study equilibrium, because in principle we can find the torque that a force exerts about any point. Okay, all that will become clear in the forthcoming videos. So the torque about point P, the magnitude is simply RF sine theta. Now it is a vector quantity, and so we also need to be able to identify the direction correctly. Okay, let's first get a simple idea into our minds. Like in our situation right now, if you have a rod that is pivoted at this point P, the force is pointing in this direction, you see that this force would cause this rod to move in a counterclockwise sense. Okay, on the other hand, if I had a situation that looked like this, okay, once again it's pivoted at this point, but now the force is pointing in this direction, this would cause it to rotate in a clockwise sense. Okay, we will say that all counterclockwise directions, okay, that those will be positive. Okay, will be positive, and then the similar we'll call the clockwise rotations negative. Okay. Okay. Now, what does this positive and negative mean? From your vectors, okay, you would have learned something about cross product of vectors, and if not, here's a very simple way of looking at things. The cross product, if you have two vectors A and B, and we're going to do a cross product between these two vectors, then what we know is that the vector A cross B is perpendicular, okay, to the vector A and to the vector B. So essentially it is perpendicular to the plane formed by A and B. So if you have a plane and you have the vector A here and the vector B here, okay, then the vector A cross B is perpendicular to this plane. The way the direction is identified correctly, because you see we have two choices for this direction. It could either be pointing up or down the plane, but the way the direction has been, the conventional direction is that if you were to take your right hand and place it at, place it open at A, and if you were to turn it into B, okay, the direction of your thumb would end up giving you the direction of the vector A cross B. So in this situation, A cross B would be pointing up. On the other hand, if you had B cross A, then once again you put your right hand aligning with B, okay, and then you take it and you rotate it into A, and then you end up getting B cross A. And you see that these are two completely different vectors, and what we understand is that A cross B is simply the opposite of B cross A. Okay, so as far as we're concerned, as far as torques are concerned, okay, in our example, going back to our picture, I'm going to redraw it quickly here. If I have this particular situation, the force is F here, this is R, okay, then this force will produce a torque which will be perpendicular, and if I were to take my R and turn it into F, okay, so if I were to draw simply the vectors, my R would be pointing here, F is pointing somewhere here, and if I were to spin R into F, the thumb would be pointing out of the plane, so we could denote the torque as simply, you know, with a dot, where the dot simply represents out of the plane. Okay, and in the case of this other picture where the force was pointing downward, okay, we would have the torque going into the plane, which would be represented with a cross. Okay, so in the first case the torque is out because it gives you a counterclockwise rotation, and if you think of it as opening up a bottle, you know, to open a bottle you turn it counterclockwise and the bottle cap comes out towards you. On the other hand, if you were to rotate it clockwise, then the bottle cap goes away from you and into the plane of the paper. Okay, so I know it's a little confusing, but after a few examples all this should be straightforward. Okay, so now that we have the direction and the magnitude of the torque, let's just look at a few simple examples of torque directions. Okay, so for instance, if I have, let's say that this is my R, it's pivoted at this point, and if I were to exert a torque in this direction, sorry, a force in this direction, okay, what is the direction of the torque? So, you know, take your time, just do this and then check your answer. All right, so assuming that you've done what you had to do, we would see that this if I were to take my R and rotate it into F, okay, this would lead to a torque that would be going into the plane of the paper. So in this case the torque would be into the plane. Okay, also keep in mind that if R and F are parallel with each other, okay, then the torque is simply equal to 0. Okay, so you know, stuff that may come up, like cases, in some cases, you know, the force may just be parallel with that. In that case there will be no torque produced. For instance, if you were trying to open up a door, and if say the door is hinged at this point, and if you were to simply pull onto the door in this direction or push onto the door, the torque produced would be 0. Alright, so we will stop this video here, and in the next one we'll look at some examples of calculating torque for various cases and also give you a second definition of torque.